In this issue of Spacecraft Guide, we are going to go into the Orion roll indicator, which is like this up here. But before we do, we want to show you the zoom in feature. And this zoom in is just easy by clicking in the button or pinching and zooming. But we want to show you how close that can get. So this is how close we are looking at on the flight director indicator, the roll indicator on that. And if we look at the other virtual reality tour of the Gemini 7, we can see that they have a zoom feature up here, but they do not really go as close as we do. So let's look at this right here. Let's see how close we can get into it. We can get that bar into the Smithsonian's virtual reality tour. And if we go into the Spacecraft Interactive Virtual Reality edition or image, and we go back to that area, let's see, which is right here, we can zoom in. This is about what you saw before. This is how close we can get into on any part of the spacecraft. So this is the drogue mortar area firing assembly. And so you can see the serial number. You can get that close. You can get even closer. So you can get in. You can even see scratches and paint this close up. So this is the zoom function on the Spacecraft Interactive Virtual Reality tour of the Gemini 7 spacecraft. In this issue of Spacecraft Guide, we are going back to the Orion spacecraft, and we're going to look at the roll director indicator, and that is located on the control panel. So we're going to click on this, which is going to take us to the control panel, and we're going to go to the primary flight display, and then within that we are going to look at this right here, the roll indicator. And when we click on it, it takes us to the roll director indicator. Now that is this part right here, and we can see that it provides, if we read this here, it provides a numerical description of the roll of the spacecraft relative to the required attitude of the phase of flight. So this is our roll rate. Now it shows a continuous readout of vehicle body rotation rate, and the roll rates are displayed at the top. And the center mark of the graduated scale, that's next to the pointer, shows 0 rates, while the rest of the marks indicate a positive or negative rates. Now, a pointer at either end of this colored scale here, that is read in degrees per second, and these points are fly to points, in a sense that the rotational hand control must be moved into the direction of the pointer to a null rate. So usually this is in a green or blue, but here it is in red. And what this is the fly to area. So you can see this number is 100 degrees. That means we have 100 degrees of roll clockwise or to the right, and we need to go a little bit further. We need to get into this range. This is a fly to area, and we want to get into this null rate right in here. So that's what we're trying to do. And on most modern aircraft, we have this kind of a fly to rate, but it's not on the roll rate here. It's on our speed and altitude. So, and then on our direction on the what we're turning to towards towards our map on the route that we're supposed to go on. This is actually turning the attitude of the spacecraft. And that is basically what the astronauts use to make sure that their attitude is correct for maybe like docking. They have to move the spacecraft to a roll of the aircraft so it lines up on the docking. This is all what the astronauts are going to use and they're going to try to fly within this band. So that's all for the normal section. If you are a paying subscriber, we're going to go into the schematics. Basically, I'm going to go over a diagram of how this works. So if we go to schematics, and if you are a free or paying Patreon subscriber and you click on it, it takes us to the diagram of the guidance and navigation and hardware and the GNC software for our guidance and display. And you see we have the GPS, which is the global positioning system, which are the satellites around the Earth. Then we also have the IMU, the inertial measuring unit, which is really big even now in spacecraft. As you can, well, this diagram actually comes from the space shuttle, and this is the best diagram I could find right now. And then there's also the radar altimeter. Again, since it's the shuttle, that's giving a reference to above the Earth. Now, all that information, the altitude, the attitude acceleration, all of that comes in here to the GNC computer, and it gives position, velocity, attitude data going to navigation, accelerations. And then that takes the position, velocity, attitude parameters that we want to be flying in, like that fly to area of the bank error scale that I showed you, and that goes into the guidance. So that's what you're going to see. Now, if you are a paying Patreon subscriber, we're going to go even deeper, and we're going to explain about that, the data on where this all comes from. So if you are a paying subscriber, which comes to about $4 a month or a price a cup of coffee, and you click on General,